Hello, today we will learn how to do subnetting for a class B IP addresses. So before I start my session, let me tell you this video is a free tutorial from udaynetworkacademy.com, which gives out CCNA, CCNP personal training, one-to-one sessions, as well as network security training. So coming back to our topic for today, subnet mask class B. So before I start evaluating the class B addresses specifically, let me tell you a technique for subnet mask calculation. Now these ones, what you are seeing here, there are 8 ones representing 8 bits of octet. That's first bit, second bit, third, fourth, and so on. Now bit each bit has a value, that is 128, then 192, and 224, 240, 248, 252, and so on. Now these values are used for calculating subnet mask depending upon the number of network bits which are used in that particular octet. Let's start with class B, and I'll come back to this technique again. So let's take one example. The overall, what we will do is we will determine the number of network bits, then we'll evaluate the subnet mask, and then we'll calculate the total number of subnets, and then we'll work on the number of subnets block. First example, let's take a class B IP address 172.16.0.0. The requirement is to have at least 500 hosts in a network. First step is to find out the nearest multiple of this number 500. That is multiple of 2, nearest multiple of 2 for this number 500, which is 512. So it's obvious that you must know the powers of 2 to do this very fast. So 512 is equal to 2 to the power of 9. Now this 9 indicates the number of host bits. This 9 indicates the number of host bits. So next step is to find network bits, which is pretty easy. All you have to do is subtract the host bits from the total number of bits, which is 32 minus number of host bits. 32 minus 9 is 23. So this is the number of network bits. Next step is to calculate or evaluate subnet mask. It's very easy. All you have to do is distribute the number of network bits, which is 23 bits, among the octets. So 8 plus 8 is 16. 16 plus 7 is 23. So 887, and then the host bits. So 8 bits is 255. You know the subnet mask calculation technique which I told you. Or if all the 8 bits are used, then the value you will be using is 255. So 255 here, again 8 bits, so 255. Now if you are using 7 bits, it is 254. So 254 here, and then 0. So that is the subnet mask calculation. Now next step is to calculate the number, find the number of subnets, which is again easy. It's 2 to the power of 7. Now where does number 7 came from? From this octet, the third octet, which is 2 to the power of 7 equals 128. So total number of subnets here are 128. Now the number of subnets per block, you can see here, subnet block is very easy. It's 2 to the power of 8 minus 7. 8 is the octet, and 7 is the subnet bits we have used from the default value, which is 2 to the power of 1, 2. So the number of subnets we have is 172.16.0.0. The next subnet is 172.16.2.0, and then 4.0, and then 6.0. So that's how we progress. continuing with the class B subnetting, we'll take another example here. The required number of hosts now is 1000. Now if it is 1000, then again applying the same technique of power of 2, the nearest value of 1000 is 1024. So 2 power 10 is 1024, which is the nearest value to 1000. So 10 is the number of host bits. Now that we have found number of host bits, again number of network bits is 32 minus the number of host bits 10 in this case, so it is 22. Once we find the network bits as 22, evaluating subnet mask again, distributing 22 into octets, 8 bits plus 8 bits plus 6, that's 22. So for 8 bits it's 255 and 255, and for 6 bits it is 252. 252 for 6 bits. Continuing further, total number of subnet calculation is 2 to the power of the subnet bits, which is 6 here, that's 64, and subnet blocks, it's 2 to the power of 8 minus 6. So that would give us the number of subnet blocks, which is 2 power 2, 4. So first subnet is 172.16.0.0, or second subnet is 172.16.4.0, and then 8.0, and so on. That's an example if the required number of hosts are 1000. Let's take another example here. If the number of required hosts are 2000, again applying the same principle, power of 2, 2 to the power of 11. So 11 is the number of host bits. Network bits is 32 minus 11, that's 21. Subnet mask is 21 distributed equally into octets, that 8, 8, 5 and 0, that's 255, 255, and 5 bits it's 248. 248 5 bits. So total number of subnets is 32, and subnet blocks, total number of subnets is 32 because it's 2 power 5, 32. Subnet block is 8 minus 5, that's 3, that's 2 power 3, 8. So 172.16.0.0, 172.16.8.0, and 172.16.16.0. Next example, if the required number of hosts are 4000, then power of 2, 2 to the power of 12, 12 is a host bits, 32 minus 12, it's 20, and subnet mask is 8, 8 and 4. That's 255, 255, 240.0. Subnet block is 8 minus 4, that's 4, so 2 to the power of 16, so 2 to the power of 4 is 16, so 16 is the block size. So 172.16, 0, and then 172.16, 16, 172.16, 32, and so on. And you know how to do the rest of the things. Thank you very much. I will try to give more examples. Moving on to the example of subnetting on class B. So we have a question here. What valid host range is the IP address 10.152.113.23 with this subnet mask of 255, 255, 240.0 a part of. We need to find a valid host range to which this IP address belongs to. So what we are given? So we are given the subnet mask 255, 255.240.0. The first thing to determine here is the block size, the subnet block size. To find that, we use our old technique of subnet mask calculation, that is the number of bits which are used. Now here in the third octet of the subnet mask, it is 240. This is the subnetted bits. So 240 is at the fourth bit. So 4 bits are used. Very simple. So block size is 2 power 4, which is equal to 16. 16 is the block size. Now all we have to do is write down the subnets. So 10.152 dot. Our first subnet will be 0.0. Remember here, subnetting is done at the third octet. So the first two octets, all bits are used. That's why it is 10.152. So the next two octets is where we are interested in. Okay. So first subnet is 0.0. The second subnet would be 10.152.16.0. Third octet we are doing subnetting. So 0, the next block is 16. What will be the next block? 10.152.32.0, and then we'll continue until we go to 10.152.112.0, and then the next block is 10.152.112 plus 16, that's 128.0. So how did we get to this value of 112 here? It's very simple. It's just a multiple of 16. It's just a multiple of 16. Just keep on adding 16 multiples and you will get to one particular subnet which falls under a required subnet. A required IP address is 113. So we are interested in looking between this subnet, this network ID and this network ID. It's obvious that this IP address will fall between them. So I'm just going to take this subnet and write down first valid IP address, which is 10.152.112.1. The last valid IP address would be 10.152.127.254 and 10.152.127.255 will be the broadcast address. We are not interested in the broadcast address. We are not interested in the network ID. We are only interested in the host range of the IP address. So it is between 112.1 and then 10.152.127. So obviously there will be at some point 10.152.113.23 will fall between this range. So that's our answer. Very simple. No complex calculation. All you have to remember is determine is the block size and then find out the multiples of the block size. 16, let's say for example 16 5s are 80. So 80 again, next is 96, and 96 plus 16 it's 112. So that's how you have to calculate. It will become easy as you practice a lot. So that's an example for class B. We will work on another example